Alright, let's look at example 1. We have to prove tangent square A equals sine square A secant square A. So for first strategy, you must always start from the more complicated side. Which is the more complicated side? Is it the left side or the right hand side? Can you see the right hand side is more complicated? So we start from there. Right hand side equals to sine square A secant square A. We have mentioned the strategy number 2. We must make use of one of the reciprocal trigo functions. And we see that secant A is 1 over cos A. So if likewise, I have secant square A, and I say secant square A is equals to I square 1 over cos A, which I get 1 over cos square A. So now I can replace sine square A times what we have here, 1 over cos square A. Then we have sine square A over cos square A. Are we getting there? So we know tangent A is actually equals to sine A over cos A. Basic trigo identity at the start. So right here I can change it directly, or if I rewrite this, is sine A over cos A square, and it's sine A over cos A is tangent A square, so it's tangent square A. So this for the first example. Let's look at the second example for B. So which is the more complicated side again? So I see that the second one, the right hand side is the more complicated. So right hand side I copy down. So I look at tangent square theta, can I apply one of the formula? So if I look at the formula in front, I would have secant square A equals to 1 plus tangent square A. So what can we do? Realize that tangent square A is equals to secant square A minus 1. So I replace tangent square theta with secant square theta minus 1 over secant theta minus 1. Oh, then what can we do next? How can we get closer to our left hand side? Do you realize that secant square theta minus 1 is like the fourth strategy where we have to apply the special algebraic identities. So secant square theta minus 1 square. Can we apply this a square minus b square equals to a plus b times a minus b? So I replace this with secant theta plus 1 times secant theta minus 1, whole thing over secant theta minus 1. Now that I've changed to something times something over something, can we reduce and simplify the fraction? Okay, we have now secant theta plus 1. So what's the next step now? Can we apply the strategy to make use of one of these trigo identities that we've learned, which is the reciprocal trigo functions? Secant theta is equals to 1 over cos theta. And then finally, do we have the strategy number 3 where we say we combine the fractions? Okay, that means strategy 3, combine fractions, two terms, combine it to one term. So if the denominator here is cos theta, and I say I multiply by the 1 by cos theta over cos theta. And I have the same denominator cosine theta, which is exactly what we want on the left hand side. So I have 1 plus cos theta over cos theta, and it'll be equals to the left hand side, and we have proven it. So over here, we realize that we applied different strategies for the different questions. We must always start from strategy number one. We start from the more complicated side.